Hello, and welcome to another Unreal Engine 4 tutorial. This video is going to be a little bit different than my other videos because this time we're going to be working in Cascade as opposed to Niagara, and I'm going to explain in a few minutes why that's the case for this effect. I originally started in Niagara, but I ran into some issues, so we're doing this in Cascade. But before I get into that, essentially what we're going to be making here is a portal effect, so not like Portal the game, but like an interdimensional portal that's kind of unstable and cool looking, has some distortion effects to it. We're going to use a lot of different cool techniques to make this happen. So we're going to be using Macro UVs, we're going to be using directional masking, and a few other neat things like a parallax texture to make this effect really come to life and give it a lot of little small details. So without further ado, I'm going to jump in and we're going to start explaining why we're doing this in Cascade first. So I've got my folder system set up here, so I'm going to go into this portal folder. And the first thing we're going to do is create a material, and this will be our portal material. And I'm going to start off real simple here and just explain the basis of what this effect is going to be doing and how we're going to be doing it. So first thing we're going to do is switch the blending mode to translucent and the shading mode to unlit. It's going to provide its own lighting. It's going to be emissive, translucent because we're going to need the particles to fade in and out. So we'll just apply that. And then we are going to add a special node here that is super cool, very useful. It's called particle Macro UVs. And so I'm going to demonstrate this to you in a second. So what we're going to first need to do is we're going to need to get a texture sample. And I will just grab quick texture or something I have in here. Let's see. We're gonna let's grab Waldo. So we've got this Waldo texture here, and he's gonna help us explain how this works. So we're gonna look for Waldo, and we're gonna plug the Macro UVs into the texture sample. And then we're just going to plug that into a emissive. And we're going to get a lot more complicated with this later, but we're just going to start off showing you what this looks like. So we have our texture that is being fed particle macro UV information. Now we need to make a real quick particle system to take advantage of that so we can show off what this is actually doing. So first thing we're going to do is we're going to create a Cascade particle system, and we'll show with this exactly how it's supposed to work, and then after that I'll show what Niagara is doing, which doesn't provide the intended effect, and then we'll sort of talk about why that is and then move on to just actually creating the particle system. So we want to look for our material that we just made and set that to the material for the particle system. Then we want, you can already see it's kind of working, but I'm gonna make some base changes to the particle system so that we can see a little bit better what it's doing. So we're just gonna, these aren't gonna stick around. We're just gonna change these for now, just so that we can see a little bit better what's happening. So we're gonna make this 100, 100, negative 100, negative 100, and negative 100. That way we get particles going in every direction, and we are going to make the size a little bit bigger so that we can see things a little bit better. So these are sprites, so we're just going to go 50, 50, 0 since the Z doesn't matter. So now you can sort of see what's going on. We'll drag this out into the world and we can take a look at it. So we got this particle system here, and essentially what it's doing is it's taking a texture and it's mapping it to a world space position, which essentially is the origin of the emitter. And then it's looking at these particle positions and using the particle position to inform where we're rendering that texture. So it basically is going to render the texture on the particle where the particle is, and where there is no particle, it's not going to render it. So you can see it just stays in the same place. You look at it, it's pretty neat. So essentially what we're going to be using this for is we're going to be creating a portal that gives you the effect of looking through into another dimension or another place, something like that. So the reason why we are not using Niagara for this, I will quickly demonstrate. If we go to FX, Niagara emitter, and we're going to do an omnidirectional burst. We're going to call this PN portal and open this up. We need to change a few things. We're going to delete the gravity and the drag force. And you don't actually need to do all this. It's just me demonstrating. You can follow along if you want to. We're going to get rid of the calculate size by mass, and we're going to add sprite size. We're probably just going to go, I think, with 50 and 50 for that like we did before. So you can see this is now spraying out like that. And we're just going to go and we're going to apply our same material, which is in portal. Once again, that for some reason, every time you apply a material to a particle system, it does that. So you can already see some things are going wrong here. We're going to drag this out into the, or we got to create a particle system, Niagara system, and then open that so it compiles. And then we're going to drag that out in the viewport and take a look at what's going on here. So, oh, I forgot to change. So it's bursting, which is fine. We'll just change the loop count to 0 so it just keeps going so we can actually take a look at it. So you notice a lot of things are wrong here. First of all, it's upside down. It is offset a little bit from what the other one was. It's also stretched. And all those are pretty simple things that you can fix in the material through simple mathematic translations of the macro UVs. The real problem with this is if we pan the camera, it pans the texture as well, because it appears that instead of mapping the texture to world space, it's mapping it to screen space, which kind of ruins the effect of looking through into another world if it looks like the other world is just smacked on your screen. So we're not going to be using that. You can see the difference is pretty night and day here. One slides with the screen, the other doesn't. I don't know if this is intended behavior. I've asked around about it, and I talked in the Unreal Slackers Discord to an Epic staff member who said they were going to open an issue for it and look into it. So this might just be a bug that'll get fixed, but for now, it makes it pretty difficult to do the effect that I want in Niagara, so we're going to do this in Cascade. I tried, trust me, endless amounts of different things to try and get this thing to not scroll with the camera or to pan against the camera actively, but the vector math is beyond me. I'm not a genius. I'm not a mathematician. So we're just going to go with the easy route because I've already spent too much time trying to make this work. So we're just going to delete this and we're going to delete both of these because we don't need them anymore. We're just going to stick with the Cascade one and the material we have. So the first thing I want to show before we get into the details of the particle system or the details of the material here, which is going to change considerably, I want to show you how I made the things that we're going to use here. So this is a mask we're going to be using, and then you're not going to be able to see the one that we're actually going to be using. But if I look here, you can see that I've created a star field, which is just a bunch of different grayscale textures overlaid that we're going to use for parallax material. So first I'll jump into Photoshop and we can look at creating that little mask, which is going to be the basis of the particle shape. So we want to create something that is 256 by 256. So we're going to create that. We can just make the background black. So unlock it over here. I'm using Photoshop if I didn't mention that already. So unlock the layer, make it black, and we are going to create a shape. So if you go up here, you click over here on this little thing, you can do different things with different kinds of shape. We're going to go to the custom shape tool. Then we're going to go up to the top here and you can change the shape. We're going to use this little burst, kind of like a little explosion kind of deal. So hold shift and drag it out. We want to move that to the center, and of course it made it black. So we're going to change that to white. There we go. So now that we can see it, we'll move it to the center, roughly. And what we're going to do is we're going to go to Filter, Distort, and we want to twirl it. It's going to ask you if you're going to rasterize it, rasterize it. So we're going to twirl it a little bit, about 175, something like that should be good. So that twirls it. we're starting to get sort of the shape we want, which essentially what we're going to have is like wispy curves coming off the edge of the shape to make it look like this portal is kind of unstable. So we're going to go back to filter, we're going to go to distort, and then we're going to go to spherize and just leave it at 100%, hit OK. Ooh, that kind of messed up for some reason. That's unusual. That has not happened before. It might be, let's change the amount of twirl we give it. So just a little bit more twirl so it doesn't mess up like that, hopefully. Oh, I can already see that happening again. Well, hopefully it will not do that again. So spherize. I don't know why that's happening because it's absolutely not happening in the preview. Interesting. Distort. Spherize. You can see that's not happening in the preview. That is a little strange. I've done this like 3 or 4 times and it's never done that. So I don't know what the deal is. We can just kind of work around that though. So if we... Why won't this let me transform? Okay. For some reason that wasn't letting me transform, but we got it now. So what you want is this to be inside completely, so you don't want anything overlapping with the edge to give you hard edges. And then we're just going to clean up this garbage that has, for whatever reason, been introduced. So we're just paint over it. Doesn't have to be perfect. The other thing that I was going to do anyway is kind of remove some of these pixelated looking trails so we don't have a lot of noise around the edge there. So just about done here. Okay, so that looks all right. Maybe kind of tweak some things if you want to, but essentially we want something that's a little irregular so that you never see the whole thing at once, but you'll see different parts of these shapes around the edges, so it constantly looks like it's in flux. I already have this exported, but you could basically do the same thing and then export it. And you'd also probably, just in case you're unfamiliar with Photoshop, you can go to export as here. You want to export it as a PNG. You can also turn off the transparency because you're literally just using black and white image. You're just using it as a mask, so you don't need the transparency. But I'm just going to use the one I had before, and I'm going to drag that in to here. So we got that spiral. And so that is going to be the first thing that I dump in here. So we're going to just drag that up here. Put that there. So we're going to do a couple things here. We want a particle color node. Particle color. We're going to multiply this color by this. Plug that into emissive. And we're going to multiply any of these channels. Doesn't matter because they're all just going to be grayscale images against the alpha coming out of the particle color, and we're going to put that into opacity. And you apply that, and you can go look and see. For some reason that didn't update. There you go. So you can see our shapes in there now. But that's not the only thing we need. We also need the image that's going to be the background of this. So I made this image in Substance Designer. And if you don't know what it is, it's a node-based procedural texture generator. So you can make a lot of things like tiles for, flooring, roofs, or leaves, or any kind of things that you want to make in here. Sky's the limit. You just kind of have to know your way around the nodes. Essentially what I did was I created this little starburst here that looks all right. It looks kind of like a star. We're just going to vary the size a lot and tile it a bunch. And so basically what I've done here is then plugged it into 2 different tiling generators, one a little bit bigger than the other one. See, these are a little bit smaller. And I just tried to randomize it as much as I could. I probably could have done a little bit better job, but I just wanted to get the gist of it. And so basically these are outputting to single images, which you saw in my folder. I had each of these things as single images. I'm also going to combine them in a second. I'll show you what I do with that. But what I also did, I've got a sort of linear gradient here. Well, not linear, but a gradient that comes from both sides here to create like a ray. Then I multiply that against a dirt gradient to get kind of a dust cloud looking effect. And then I multiply that against another spot effect noise to get sort of like discrete looking clouds. And then I'm using a morph to turn those clouds into something that looks a little bit more like gas clouds that you would have in outer space. And then I'm swirling that to kind of get like a horsehead nebula kind of effect here. So that one then plugs out. And then the third thing or fourth thing that I'm using here is just a moisture noise. And then I'm using this blend to basically blend black on top of it and just cranking the opacity up on the black so that you barely see anything. And you can't really see it here, but when it gets output, it's a very like subtle, like space dust kind of effect. And then that is going out here. And then what else I've done here is that I've blended all these things on top of each other to make just a grayscale image that shows you what it looks like. And you still can't really see the space dust here, but you'll be able to see it in Unreal when I multiply it by a different color. And then the other thing that I've done here is a technique called gray packing or color packing, which is essentially taking a bunch of different grayscale images and packing them all into different channels of a single image. So we're packing 4 different images into the red, green, blue, and alpha channels of a single image, and then outputting that image. And essentially, the idea is that you can, if you only need a grayscale image, you can pack a bunch of grayscale images into a single one to save space. Some things to note is that A, they're only grayscale. B, the alpha channel you can use, but the alpha channel uses something, I think, like twice as much memory as the other 2 channels. So if you've only got like 3 or 4, you might want to use a single texture. But if you got like 5 or 6, you might want to use 2 different textures as opposed to just packing them all into the same texture and using the alpha channel. And in Unreal, you can actually take an image and strip the alpha channel out of it after compression. So like if you're really trying to cut down on space, that's something to keep in mind, is that the alpha channel is a little bit more expensive. But in the end, essentially what I've got from this whole process that I just explained is a single packed texture that I will now bring in. I just called it RGBA combined, which is not a good name, but since this is a pretty simple project, it'll work fine. So if we turn off most of these channels, you can see we've got our big stars here, we've got our small stars in the green, we've got our nebula, which is kind of hard to see right now on the blue, and then we've got space dust on the alpha, which you cannot see at all. But again, once we get into this, you'll be able to see that much better. So what I'm going to do now is I'm going to start working on breaking those textures out. So we're gonna actually just disconnect these things for now, and we're gonna grab this RGBA combined texture. So we'll have one texture here. You can see it's displaying the different colors in here, because if you display it as a single image, it will display that way, but if you break it out, you'll have the grayscale textures. And I'm gonna make 3 copies of this. And that might seem strange at first, but you'll see after I get into making a parallax effect why this is necessary, because each of these essentially needs to have its own UV coordinates being fed in to be able to offset the textures from each other. So we've got our 4 textures in here. Now what we want to do, and I'm just going to create a component mask here to feed into this. So that when I make changes to the UVs later, I don't have to feed this back in every single time. Or actually, I'm probably gonna have to change this anyway, because these are all gonna have different inputs. But for now, just for display purposes, I'm just gonna feed these in through here. So what we want to do is we want to get some lerp nodes. And if you're not familiar with a lerp node, it's a linear interpolate. And essentially what it's doing is you're feeding in 2 different values, or 2 different images or values and an alpha, and then the linear interpolate is figuring what it should show for each pixel based on what the alpha is. So things that are pixels that are closer to 1 are going to display B, versus ones that are closer to 0 are going to display A. And it fades between the two. It interpolates between the two. So the very first one we want to do is we want to lerp in the space dust in the background, and then we want to lerp over that with the nebula. So the nebula is going to be its own alpha, and just say where there is nebula information, put that on top of the space dust. Then we're going to grab that and we're going to put that into the alpha, or into the A of the next lerp, and then we're going to say the small stars are going to go over that. Same setup, and we're going to put this one into the A up here, and then we're going to grab the red channel, which is the big stars, and then we're going to plug that in, and then we're just going to slide this over, and we're going to throw this in here just to look at what this looks like. So if I have not messed anything up, which I don't believe I have, we should just have, yeah, so you can see in there, we've got our texture. It's in grayscale right now, so the very next thing that we want to do is we want to make this a little bit more interesting looking. So what we're going to do here is we're going to multiply the big stars, and we're going to multiply them by a pretty large number so that they're the brightest things in this image. And then we're going to duplicate this. It'll duplicate. We're going to duplicate that, and we're going to multiply the small stars by a slightly smaller number, or half as much. And we're going to plug those back into the B channel for both of those respective things so that they're being lerped in. Then what we want to do is we want to add some color to the space dust and the nebula. So we're going to start off, we're going to make a color parameter here, and we're going to call this nebula color, so that we can later change this in a material instance without actually having to tinker with anything. So I'm looking at the wrong thing here. So I want to plug in the blue channel for the nebula into this multiply, and then plug that into the B of the lerp. And then I want to get this color, and I want to multiply that times the nebula. And then the color that we're going to use is going to be 38.4 and 0. So it's a nice orange color. And then we're going to duplicate this, and we're going to change the name to be, whoop, that did not do what I wanted that to do. We're going to try that again. We're going to change this to be space dust color. And then we're going to multiply what's coming out of the alpha here by this color, and we're going to plug that into the A channel. And then we're going to change the color to be 0.72 and 2.5. So if we save this and we take a look, we should have a much nicer range of colors. So you can see it, the image looks a lot more interesting. Actually, if I go change the initial size of these particles so that they're bigger, we can actually see this a lot better. There we go. So now you can see we've got some bright big stars, some slightly fainter smaller stars. We've got bluish space dust in the background, which provides a nice texture to it. And then we've got our nebula coming in here with a nice orange, bright, gassy color. So now we've got that going. So the next thing we want to start working on, so we'll just, we'll comment this out and we'll say this is the texture layering. So we'll just drag that up here. The next thing we want to start working on is our parallax effect. So there are a lot of different ways to achieve a parallax effect. There is a bump offset node, which is really useful. We're not going to be using that here because when you start rotating particles with macro UVs, you start to get a really weird effect with that. So what we're going to do instead is the one that I have found the most useful for what this effect is doing, and it works from every direction that you could look at it. So in a minute, I'll once I've worked all this out, I'll make a copy of this and make a version that can just go in a cube so we can look at it. But we're going to get a screen position node, and we're going to subtract viewport UV from pixel position. So this is essentially just getting us a movement vector when the camera is moving with respect to the particle system. So we're going to subtract those, and then we are going to we're going to mask this so we can just plug things in much easier. If we need to make changes later, we can just, like I said before, we can just grab what comes out of this and plug it into something else, and then make the changes on the other side of this, so we don't have to keep shuffling wires constantly. And the other thing is, like, this is a UV, and R and G are essentially corresponding to UV here, so this node is not really doing anything. It's like a redirect node for us right now in Blueprints. So what we're going to do now is we're going to get a bunch of divide nodes, because we need to scale this. We're going to plug this into every single one of these divide nodes. And we're going to divide by a range of different numbers here. So the big stars are going to get the smallest number, which is still a pretty big number. It's going to be divided by 4,000. The small stars are going to be divided by 6,000. The nebula is going to get 8,000. And the space dust is going to get 16,000, because it's just supposed to be the background noise. It can pan a little bit, but we don't really want to pan it too much. And then what we're going to want to do is we're going to want to add this to our macro UVs. So we want 4 add nodes. And we're going to add all of these to the macro UVs. Just shuffle these wires here real quick. And this is why mask nodes are useful, because after we do this, we're not going to have to do a lot more of these shuffling of nodes, because I've made all these mask nodes. And when I make changes later to what the macro UVs are doing, I can just put that on the other side of the mask node and only move one wire. So now we've got this all set up. So theoretically, when we go look in the viewport, we should be able to, I should turn the camera speed down here a little bit. You can see that it's moving a bit. And to get a better look at this, we can duplicate this and just call this parallax test. And then we'll just decimate some of these things. So we'll get rid of this. We'll put a texture coordinate and plug that in. We will get rid of those things, and we're just essentially, I think this should work now. We're just essentially getting a texture, a static texture that does the same thing that the particle texture was doing. So if we go look at this, yep, perfect. So we might actually want to scale that a little bit. So we'll give it, I don't know, 6. Okay, well, that was a little bit much, but it works. You can see essentially what's going on here. There's panning. It's panning in the same directions on every side of the cube, so that we now essentially have a parallax effect added to our material. So that works. That's nice. Now what we're going to do, now that we've got a solid basis for the material, we're going to come back and do some things to it later, but this is a good starting point. We're going to go into the portal particle system, and we're going to change some things to what we need in here. So first thing we're going to do is we're going to go to spawn, and we're going to go and turn off process burst list. And essentially what this is saying is that there's going to be no bursting element to this particle system. So same sort of deal that we would have in Niagara, but just a different way of applying it in here. We're going to go into rate, and we're going to change that to 15. I don't know if the scale, so this is scaling the rate, and it's just scaling it by 1, so we're not changing anything there. And then we want to go into lifetime here and change that from 1 and 1 to 1 and 3, so there's a little bit of variety in the lifetime of the particles. And then we already did the initial size, so that's perfect. We want to go into color over life, and we're not going to change the color itself, we're just going to change the alpha. So we've already got 2 points in here, but I think we want 4 points, so we're just going to click to add 2 more. The first point is 0, 0. The second point is going to be 0.15 and 1. The third point is going to be 0.85 and 1. And the last point is going to be 1 and 0. So essentially what it's doing now is they're fading in over 0.15 seconds and then fading out over 0.15 seconds, and they're opaque for the rest of their lifetime. So that way they don't just pop into existence. And then we are going to add an orbit node. And orbit node's pretty neat. This is not in Niagara. It's pretty useful. Essentially what it's doing is it's drawing a rendering around the particle. So there's the particle, and then it decides where to render what the particle looks like with respect to where the particle actually is. So if we look at, actually I think it's up here. If we click this little button here, this renders different things. So you can see these crosses themselves are not moving. That is the actual particle position. But then if we look back at the materials, well, there we go. If we look back at the materials, they look like they're rotating. So it's not rotating the particle, it's just rotating where it's rendering your material around the particle. So again, you can see that they don't move at all. Or they don't rotate at all. They do move, but they don't rotate. So it's a super useful module for creating these interesting movement effects. And we are going to take advantage of it here. So we want to change this offset to make sure that the offset is always constant on these things. So we're just offsetting on the Y 50 to 50, min and max. That's all we're going to do there. Then we want to go to rotation amount. And what are we going to do? We're going to do 1 to 1 on the X and the Y, I think. And then we're going to go to rotation rate amount. And we're going to go get rid of the X rotation rate. And the Y will be, and the Z rotation rate. We don't want that. And the Y will be 0.5 to 1. Let me check to make sure there's, we also want to get rid of the rotation amount on the Z. We don't want any Z rotation. So you can't super see what's going on here yet. So we'll just kind of forge ahead here. And hopefully it'll get a little bit clearer in a minute. So we're going to delete the initial velocity. We don't want that. It really doesn't appear to be doing much, but we'll get there, I promise. So we'll go to location, initial location, and we're going to change the Z location to be 30 and -70, and these are just numbers that I've sort of figured out. Man, it's not really... What is the deal with that? Well, I'll just keep adding things in here, and then if it doesn't appear to be doing what I want it to be doing, by the end of it, I'll make a little bit more adjustments to try and figure out why this orbit node is not quite doing what I want. I might change some of these things now. So local space, that didn't quite do it. Orientation, lock axis. Let's see, lock axis, -y. Let's see if that's not doing anything in the world. Okay, so something I did not quite do right in the orbit node. There we go. So yeah, you don't want the, apparently you don't want the minimum to also be 1. So you want the min to be 0 and the max to be 1 for X and Y rotation amount. And that gets us what we wanted. Now you can see, not perfect, but we're going to get there in a minute. So we're rotating around the center. It's kind of giving us this, this nice unstable portal effect. There's a couple more things we want to change in here that don't look great. So we want to change size by life. So we're going to go here and change this. I think we want, we'll go with 3 points this time. So the first point is going to be 0, 0, 0. So it's going to start off not existing. The second point will be at time 0.5. It'll be 2, 2, and 2. And the third point will be at time 1. And it'll be 0, 0, 0. So they kind of start small, get big, and then get small again. Or start scaled all the way to 0, essentially. Then what we're going to do is we're going to add an initial rotation rate so that they're not static. And we're going to do a distribution between 1.5 and 6. So if you haven't used this before, this is actually 1 is a full rotation and 0 is not rotating. So essentially it's, the way I've set this up is it's rotating very fast, like 1.5 times 360 or 6 times 360. So you can see it gives it kind of a crazy, almost unstable feel to it. So that's starting to look pretty good now. There are some issues that you'll notice like that, but we're gonna work on that so it doesn't look like that. So the next thing we're going to do is get into the material here, and we're going to scale this because it's not quite where I want it to be. So we're going to actually scale it up. So we're going to multiply macro UVs by 0.8. If I can get 8, plug that in. So it'll be a little bit bigger now. And then we're going to work on directional masking. And this is a really cool technique. I really like using this. We're going to be using a dot product. And if you're not familiar with what a dot product is, it essentially takes 2 vectors in and it compares the angle between those 2 vectors. And then it uses that to inform, or basically to get a scalar value. So I should probably just show this to you and it'll be a lot easier to understand. So we're gonna make a vec3 and we're gonna call this 0, 0, 1. And we're gonna plug that in. So that's just a vector 0, 0, 1. I believe, I want to say this is in world space. I'm not really sure though, but then we're gonna duplicate that. If it will duplicate. And then we're going to get a transform. Actually, I think that's in, yeah. So this is representing just the world normal, essentially. And then we're getting this, which will be 0, 0, 1. And we're going to use a transform node to say, get all the surface normals of the object that this material is being applied to, and then transform that from tangent space to world space. And then we're going to compare that against the world normal. So if we right click on this and start previewing the node, what you'll see is how it's comparing that. So essentially the world normal is pointing straight up, and then this is comparing all of the object normals of this sphere against that straight up normal. So things that are going in the same exact direction and have no angle whatsoever between the vectors are going to return a value of 1. And then as you get to 90 degrees away from the vector, it's going to return a value of 0. And then as you get to 180 degrees away from the vector, it's going to get to a value of -1. So essentially what this is doing is just comparing those angles for each surface normal. And if you're having trouble picturing this, if I can open up, some engine content here to, well, let me, I don't actually know where that is stored. If I could just find that sphere, that would be super useful. Let me just drag a sphere out here, and then, whoa, there we go. Okay. So if I click normals on here on the sphere, you can see exactly what the normals are. They're essentially the surface normals are where you're perpendicular to the surface of the sphere. So we've got all these different surface normals here, and essentially this is at all the vertices. So what, and we'll just delete the sphere. So what the dot product is doing is comparing those normals to the world normal, and then it's returning something else for us. We're actually going to not be using the world normal here. We want to use a specific direction because we're masking a certain direction. So what we're going to do here is instead of being on the Z, we're going to be on the -Y. And then we also want to transform this. So we're not saying local space, and I'll show why in a second. But so we're not saying local space. We're not saying just use world space. We're saying use local space. So we're taking a local space of the object this material is applied to and transforming it to world space. And then we are going to clamp that so we get values between 0 and 1, because you don't want to plug a -1 into a lerp. And then we're going to lerp. So hold down L and click. And we're going to lerp between this. So we want it to be where the normals are going the same direction. We want to show this mask, and where they're not, we want to show 0. So then we're going to plug that into opacity, and we're going to take a look at what that looks like real quick. So you see we've got this here now, and then as we go behind it, so basically as the normals are facing the opposite direction of the normal that we specified, the material just disappears because we're masking it out. So the reason why I wanted to transform to local space to world space as opposed to just using a set vector is that as you rotate this, it follows with it. So now I can rotate this portal in any direction and it'll still provide the same effect. If I just plug this predetermined world space normal in, then so now you can see it does not work that way. So I can go around it and I just can't see it because it's not at the correct angle. But if I return it back to the angle that it's looking for, then it'll be there. So that's why you want to make sure you get the local space of the object. So we're going to plug that back in. So now we've got that. And the next thing we want to do is provide a little bit of a distortion effect in here. So you can see now it's, you know, the outside of the portal is all ragged looking. It looks unstable. But if you look in the inside of it, it looks really calm and it doesn't quite feel right. I mean, you still have the parallax effect, but it's not what you would imagine a portal would look like. It would have some distortion in it. It would look like it's a little wavy, like, you know, you're having a lensing effect going on. So what we're going to do is we're going to come all the way back to our macro UVs and we're going to make some changes to them. So what we're doing here is we're going to get a texture sample. So hold down T and click, and we're going to get blurred or low res blurred noise. So this is just take a look at it. It's just a very blurry noise texture. It's very subtle changes, and that's exactly what we want. We're not going to just take this the way it is, though. So we're going to multiply it by a radial gradient exponential. So we're getting a circle. We want it to be of a radius of 1. And we don't actually want the circle itself. We want the circle to be inverted so that we're basically subtracting the inside as opposed to subtracting the outside. So if I can show that, yeah. So essentially what we're doing is we're making the circle to mask out the inside, because you want the distortion effect to be on the outside of each particle. You don't want it to be distorting the core of it. So if I just plugged this in that way, then you would have a completely different effect. So here's what we're doing. We got that. One thing is this is going to be entirely too bright. So what we want to do is multiply this times 0.1 to dim it quite a bit. So now you can see it's much darker. It's going to be a much more subtle effect. And then all we need to do is add this to our macro UVs. Whoop. And then save that. And we should have a nice little subtle but apparent distortion effect. So there you go. You can see since this is happening individually on each particle, you get sort of a ripple effect that looks like it kind of comes from the center, but the center of each particle is a little bit clearer, so you get kind of this distortion over time effect. Looks really neat. And that's pretty much all we want to do with the material itself. We're having a little bit of trouble with that, so I'm going to troubleshoot that real quick. All right, so I figured out what I had done wrong. Previously, I had put the offset amount on the y-axis. You want to do that on the x-axis, so 50 and 50 min and max on the x-axis, and then you go on a rotation amount. It's 1 and 1 on the x, 1 and 0 on the y. And then rotation rate amount is 1 and 1 on the x and 1 and 0.5 on the y. And I had previously just kind of trial and errored these numbers to get what I wanted, because if you don't have everything exactly tuned right, it won't work the way that you want it to. So essentially what the end goal was to have this just kind of fade out like that as you get sort of perpendicular to it or parallel to it. So that does exactly what we want now, and you know that those numbers are kind of the kind of thing that you'll have to do all the time making particle systems and visual effects, is just kind of tinkering with the numbers to make sure that you have got what you want and get exactly what you're looking for. But now that we have the numbers, you can see we have this unstable, let me click somewhere else. We have this unstable particle effect that is giving us a view through into space. It's got this neat distortion effect on it. It's got this parallax effect. And then as we come around the side here, it just kind of fades out into nothing. And then we can come back around and look at it from the other way, and it fades back in. So we've got a bunch of neat little effects going on here to give us this little interdimensional portal. And that's pretty much all there is to it. It's a pretty quick effect to make. It's pretty straightforward, other than the man, that's really bothering me. Other than the little bits of number tweaking you have to do to get everything the way you like. If you wanted to, you could make a material instance of this material. You could do things like parameterize all of the parallax numbers. You could parameterize the distortion. You could parameterize the colors like I did here. And then you could change those things on the fly. So you can change the colors if you want to. You could change the colors over time with a particle system. There's a whole bunch you could do with this. I just opted to make a pretty simple portal here that has a couple different neat effects going on. But the sky's the limits with this. And also this directional masking you can use for a lot of things. You could do things like two-way mirrors and stuff like that. That makes for some super interesting effects. So I hope this was helpful. I had a lot of fun making this one. I thought this was really cool. I was a little disappointed that I couldn't do this in Niagara just yet, but hopefully in the near future, that whole issue with the macro UVs will be sorted out and you could do it in there. And almost all of the process would be pretty similar. The only thing that would be different is the sprite facing works differently in Niagara, so you have to figure that out. And also the orbit module doesn't exist there. Everything does rotation in terms of physics instead of doing it in that interesting but hacky way that orbit was doing it. So you could actually theoretically make your own module that does that, but it's not functionality that's in there right off the bat. So just keep that in mind. But yeah, so that's the portal effect. Hope you get some use out of this. I will continue making videos, as I always say. The next one, I'm thinking I'm going to be doing something about render targets. So I'll be making like a security camera system that renders onto a monitor that has some distortion effects and stuff. So it won't be particle systems, but it'll be material effects and things like that. And if you have any other ideas of things that you would like to see me tackle, just let me know down in the comments. If you have any questions about this effect or any of the other things, also ask down in the comments. And if you want to see more, just stick around, subscribe. You know the drill. Thanks for watching, and I hope you have a great day.